Lesson 3.4, Quadratic Formulas. This is the third lesson pertaining to outcome R4, so it's our second last one for this outcome. Up to this point, we've talked about just general properties of quadratic equations. We've talked about how to deal with them in general form, different properties that we can pick out using the equation and manipulating the equation of the function. But some of our functions weren't factorable, and we saw that in one of our examples in the previous lesson, so we actually had to change it so that we could work with it. But there is a way to work with quadratic functions that are not factorable. Why do we factor them again? Because we need to find our zeros, our roots, our x-intercepts. So when we can't factor a quadratic function, but we still need to figure out its zeros, because they do exist and we can still graph them, they just don't have nice numbers to work with, there's another way to do it, the quadratic formula. Okay, so a formula is an equation made up entirely of variables. Those variables match up to specific values that can be substituted in to solve for whatever your formula is trying to solve for. So our quadratic formula is always used to solve for x from the general form of a quadratic function. So we're always basing it on general form, and we are going to try and solve for x. Now this only works, just like when we were factoring, when your entire equation is on the left-hand side and it is all set to 0, because we're still solving for our x-intercepts. It's just a matter of that it's not going to be pretty numbers. It's not going to be a fraction. It's not going to be a whole number. It's going to be some sort of decimal, some sort of irrational number. So this is our equation, and it looks like a beast. But I promise you it isn't as bad as it seems. It takes a couple steps. You are definitely going to need to use your calculator for this, but it's actually not as bad as it seems, I promise. Let's try using it, and we'll find out what that's all about. We start with an example where our general form is already entirely set up equal to 0, so I'm not going to have to do any moving around, so that's kind of nice. Save me some steps. The first thing I need to do is just identify what A, B, and C are, because you'll notice that those are our variables in our equation, or in our formula rather. It's always A is attached to your squared term, so A is 5. B is not just 7, but negative 7, because our general formula is written with a positive here, so if we've changed the sign, that means that the sign has changed. And C will be then negative 1 for the same reason that B was negative 7. Once we've identified those variables, is plug and chug. Now I strongly cannot emphasize enough the need to write out your equation as it is. Don't start plugging in right away, because you might make a mistake and then your whole problem is going to be all wrong. You're going to get wonky answers, things that are like, oh, red flag, like that doesn't make any sense, and you're not going to be able to piece it together. Why? So start by writing out the equation. Just x equals negative b plus or minus the square root of b squared minus 4ac. That's all under the square root, okay, not just the b squared, but the minus 4ac as well, and then divide by 2a. From here, we plug and chug. Be sure you're putting the variables in and substituting properly, so b for b, a for a, c for c, and make sure you include your signs. So we've got negative 7, because negative 7's for b, but we have a negative out in front in our actual formula. Plus or minus the square root of b squared, so negative 7 squared, minus 4 times the a value, which is 5, and c, which is negative 1. This is all divided by 2 times our a value, which again is 5. So we'll see what we can simplify. A negative and a negative is a positive, so we're left with 7 plus or minus the square root of 7 squared is 49. Negative times a negative is a positive, so I'm going to be adding 4 times 5 is 20, divided by 2 times 5 is 10. I can keep going from here. 7 plus or minus the square root of 69 divided by 10. Okay, so that's one option. So here, if you were asked for exact values, you could write your final answer as x equals plus root 69 divided by 10, and x equals 7 minus root 69 divided by 10. So that's where that symmetry piece shows up again, with our roots being kind of equal distance from each other. We'll have two roots, and they're going to be very, very similar. We're going to find them in similar ways. They're going to be equal distance from 7, and then both divided by 10. So that's for exact value. If you wanted to just write it in decimal form, you could always do that. Plug this into your calculator and you get the values from there. 1.531, and keep a few decimal places. Don't just round at 1, keep a few, because odds are we're going to be using these numbers for something else. I'm also going to get negative 0.131. When we're looking at our values, we can have exact values or we can have decimals. If you don't have a calculator, leave it in exact value form. If you do have a calculator, you can convert to decimals. Next example, unfortunately it's not in the format that we want. It's not set equal to 0 yet, so that's our first step. So we rearrange our equation, and we get this instead. From here we try and see if we can factor it, because if we can avoid using the quadratic formula, we're going to. So 9 times 4 is 36. We're looking for factors of 36 that will add to 12. Actually, we do have 2, so we're going to be able to factor this. So if you use the matrix method, I'll use that this time. I'm going to have 3x and 3x produce 9x squared. I'm going to have plus 2 and plus 2 as my two constants to give me 4. If I think about multiplying through this grid, 3x times 2 is 6x. 3x times 2 is also 6x. That is going to add to 12x. So I've actually been able to factor this. It's going to be 3x plus 2 squared equals 0. So x is going to equal negative 2/3. And I'm just going to have 2 of those values. I have 2 real roots, but they are just the same thing. If you didn't spot that this is factorable, you can use the quadratic formula. We would just need to make sure we identify a is 9, b is 12, and c is 4. From there we'd fill in x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that is negative 12 plus or minus the square root of 12 squared minus 4 times 9 times 4, all divided by 2 times 9. So that gets me negative 12 plus or minus the square root. I'm going to do this mental math wise. You could use your calculator. 144 minus 4 times 9 is 36. 36 times 4 is going to be 420. 12, 144. And the denominator is going to be 18. This whole piece is 0. I can't take the square root of a 0, it's just 0 as well. So I'm left with negative 12 over 18. And if we reduce that, it equals negative 2/3. So you'll notice that because my whole piece under the radical disappears, that plus or minus disappears with it because adding and subtracting 0 has the same effect. No effect. And so I'm left with just a single root. So either way, we get the same answer. This one is more calculation based. This is more looking at kind of the big picture and the relationships between the numbers. I recommend factoring where possible, but if you get stuck and you can't find factors, that's okay because we have this other tool to use. For C, again, we do not have this as isolated to equal 0, so we need to move some things around. We also have two binomials showing up, and we've got x on the other side as well, so we're going to have to multiply some stuff out first. So I'm going to leave the 2x over here for now. I'm going to just expand our two binomials. So that's going to give me x squared. I notice it's a difference of squares because I'm subtracting and adding the same number. So this is going to be difference of squares, subtract 1. So that's 2x equals 3x squared minus 3. Remember to distribute that 3 to both terms inside your brackets. Now I can move that 2 over, that 2x. And I'm left with 3x squared minus 2x minus 3. Again, we can look to see if we can find factors and just factor this out simplistically instead of using our quadratic formula. 3 times 3, negative 3 is negative 9, so factors would be 1 and 9, or 3 and 3. In no way, shape, or form can those be combined by adding and subtracting them to get negative 2. So this is prime, so I have to use my quadratic formula. So again, that's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Keeping going. I've got negative 2, so that's my b value here. It's attached to the single x term, square root of negative 2 squared minus 4 times a, which is 3, and c, which is also negative 3, divided by 2 times a, which is again positive 3. Simplifying this a bit, negative and negative is positive, so I've got 2 plus or minus the square root of 4 plus 3 times 3 is 9 times 4 is 36, all divided by 6. So that's 2 plus or minus the square root of 40 divided by 6. Now if we wanted to write exact values, we could leave it like this. Again, totally fine. We could even simplify that radical, and we would have x equals 2 plus or minus 2 root 10 divided by 6, and we could keep going from there. 2 can get factored out. 1 plus or minus square root of 10 all divided by 6, which would mean that my simplified answer, when I do take the 2 out of the numerator and the denominator, I could have 1 plus or minus the square root of 10 over 3. So that's one option if we apply our simplifying radicals from grade 10. If you want to go to a decimal, that's fine too. You can punch this into your calculator. So when I add the root of 40 to 2 and then divide by 6, I get 1.387. And when I subtract it and divide by 6, I get negative 0.721. So those could also be my answers. Either one is totally acceptable. Just stick to your guns. If it's in a non-calculator section of an assessment, then you're going to have to leave it in exact value, but I would totally accept this as an answer. Last one. What do we not like about this? There's fractions. So we're going to move things around a little bit and try and get rid of them. So that is always the biggest pain in the butt, having fractions and then trying to work with them. So the first thing I'm going to do is move all my terms onto one side. So I've got it all set to equal 0. So I've got 2/3 x squared minus 5/6 x plus 1 equals 0. To cancel out both of these denominators, I'm going to go with their lowest common multiple. In the case of 3 and 6, the LCM is 6. I'm going to multiply all of these things by 6, and we're going to try and simplify. So the whole side times 6, and this side times 6. Now luckily 0 times 6 is still 0. 6 divided by 3 is 2, so 2 times 2 is 4x squared. 6 divided by 6 is 1. 1 times negative 5 is negative 5x. And then 6 times positive 1 is plus 6 equals 0. Again, I'm going to check to see if I can factor this. So I'm dealing with 24 and its factors. So 1 and 24, 2 and 12, 3 and 8. 4 and 6, and there's nothing in between there. None of these are going to add up to negative 5, so I have to use my quadratic formula. So again, plug and chug. Negative b is negative 5 plus or minus the square root of negative 5 squared minus 4 times 4 is my a value and 6 is my c value, all divided by 2 times, again, 4 is my a value. Negative and negative is positive 5 plus or minus the square root of 25 minus 96. If you didn't do that in your head, that's okay. Neither did I cheated. What do you notice about what's happening under this square root here? We are getting a negative number. And when we get a negative number, we run into some problems. Please, on your calculator, take a second right now, plug either the addition or subtraction, I don't care which one you try, adding or subtracting. So 5 plus root of negative 71 divided by 8, or 5 subtract the square root of negative 71 divided by 8. No matter which one you chose, you will get an error as a message because we cannot take the square root of a negative number. Anytime we talk about a perfect square, we're talking about a number multiplied by itself. So we can never produce a negative perfect square because it's two of the same thing multiplying. So even if we took negative 2 squared, that is not going to give me negative 4. It gives me positive 4 because a negative times a negative is a positive. A thought about that, so there is no real roots is what we're going to say. This is impossible. So that is a possibility. You are going to run into that every once in a while. Be careful. Always double check that you have plugged in all your values correctly before you assume that the calculator says it's impossible, so it's impossible. Double check what you've done. R5 is kind of integrated into all of our lessons here, so we're going to apply it again. Leah wants to frame an oil original painted on canvas measuring 50 centimeters by 60 centimeters. So again, I'm very visual. I'm going to draw this out. So it's going to be 50 centimeters by 60 centimeters. Before framing, she places the painting on a rectangular mat so that a uniform strip of the mat shows on all sides of the painting. So she's placed it on another mat. So this is my painting. It's very modern, diagonal lines, and she's placed it on a mat so that there is equal distance from all edges. So we don't know what that distance is, but no matter which edge we're going from, it's going to be the same. So that's what lets me assign those X's there. I don't know what it is, but it's the same in all directions. The area of the mat is twice the area of the painting. So area of my painting is half of the area of my mat, or vice versa. Area of the mat is equal to 2 times the area of the painting. How wide is the strip of exposed mat? Well, how do we calculate area in general? Area is length times width. So we look at, do we know the values of the length and the width for the area of the painting? Absolutely. So it's length, which is 60, times width, which is 50. So that side's great. This side, it's a little bit more complicated. I'm looking for the whole width this way. So that includes both my x's and the original painting measurement, which is 50. So written this a little too close together. So it's going to be 50 plus 2x. Horizontally, I'm going to include my length of the painting plus x on both sides, which means it's going to be 60 plus 2x. From here, we need to solve for x. The first thing we're going to do is try and get all the x's together, so we need to FOIL, we need to expand. So we do first outsides, insides, lasts, and we get 3,000 plus 220 x's plus 4x squared, and on the right hand side we get 6,000. Again, you can use your calculators for that if you need to, otherwise 6 times 5 is 30, add your zeros, so that's 3,000, times 2 is 6,000. Right now we can't factor it because I don't have it set equal to 0, so factoring would be pointless. I'd just be going backwards and working against myself. So I got to move that 6,000 over. I'm also going to rearrange this so it's in my general form, so having my highest degree, that degree of 2, first. So we've got 4x squared plus 220 x's, and then subtract 3,000 equals 0. 4 goes evenly into all of these terms, so I'm going to factor it out. So I'm left with x squared plus 55x minus 750. From here, I can divide that 4 and get rid of it if we don't want to kind of hang it around. 0 divided by anything is still 0. You're not going to have anything left over, so we're just left with our trinomial. Now at this point, you can still keep working with mental math. I'm going to prime factorize this. You could use a calculator to find factor pairs of 750 that could give you 55. So when I list my factor pairs of 750, I've got 1 and 750, the obvious ones, 75 and 10. But remember it's negative 75, so even if I subtracted, that's not getting me to 55. Now it just so happens that 25 and 30 are factors of 750, but because we need opposite signs, they are not going to be able to give me that 55. So that's a common mistake. People will spot this and be like, oh yeah, but negative 750 needs that one of these also needs to be negative. So I can't factor this. It is prime. So what am I going to do? I'm going to use my quadratic formula. We've got negative 55 plus or minus the square root of 55 squared minus 4 times 1 multiplied by negative 750. Just a small number, no big deal. And dividing by 2 times 1. Subtract 55, add or subtract the square root of, I'm going to type this into my calculator, there's no way I'm doing that in my head. Make sure you don't drop the negative on that 750, and don't forget you're subtracting the 4. So I'm doing the square root of 6,025, all divided by 2. From here, because I'm looking at a specific measurement, I'm going to convert it to decimals. I'm going to use my calculator. I'm not going to try and simplify my radicals because we're dealing with numbers that are so big that they kind of lose their meaning if we leave them like that. It's hard to imagine what the square root of 6,025 is. So I'm going to punch it all in. My option 1 is 11.3 centimeters. Or my second option, if I subtract, is negative 66.3, which makes sense. Does it make sense to have a negative measurement? Absolutely not. So 11.3 centimeters is my final answer. This is a little bit more complex than our formulas from our previous unit, but it is still plug and chug. So there are lots of practice questions. Make sure that you remember you can leave it in what we call exact value form, or you can convert it to decimals. I recommend if we are talking about a word problem, we convert to decimals so we understand what that number means.